guys, welcome to this video and welcome to Kudi Python Lab. In today's video, we want to perform analysis using a stational diabetes data set. Here we have this data set, and these are the analysis that we're going to do. We're going to use Python and to perform this analysis as well. So at the end of the day, we're going to train the model as well, evaluate the model, and save the model for production. So this is everything we're going to do in this video. You stay tuned with me, and we're going to start from the very beginning till we are done. Let's go in there. So guys, I've created the project already. I have a folder, Gestational Diabetes. If you open this folder, you're going to see another folder, data folder, where I have the data set for this analysis. The link of this data set will be on the description box below in this video. And we can open this data set. It's in a CSV format. So we can have a look at this data set normally. So this is the data set we're going to perform analysis on, and we're going to use it to train the model. It has variables like age, pregnancy, pregnancy number, weight, height, BMI, heredity, and the target variable, which is the prediction itself. So this is the data we have. The link to this data set will be on the description box below for you to download and follow up. Do well to follow up. If you have any question about the data, you can always ask me. All right. So I have opened the folder in Visual Studio Code. I'll be using Visual Studio Code for this analysis. So I've already installed Python. For you to follow along with me, you must install Python on your system. I have installed Python already in my system. So you need to install Python, then and Visual Studio Code. Then you have to create a folder called data and copy the data down here. This is the same data I showed you before. Now I'm opening from the Visual Studio Code. All right, so once you have this in place, you can follow along with me as we start the analysis. So first off, I like to create virtual environment for my work. So we'll just quickly create virtual environment here while we continue the work. So I'll just click up here, terminal. Then I have new terminal down here. So I have the terminal in Visual Studio Code. To create virtual environment, you're going to type Python. If you are using Windows operating system on your laptop, you're going to type Python-N PENV, then the name of the virtual environment, PENV, ENV, then the name. I'm going to name it ENV. So this is the command you need to type. You can name this particular one anything, right? If you are using Windows operating system on your computer, this is the command you need to type. But if you are using Linux, I'm using Linux, you're going to type Python 3, right? Because the package for Python is Python 3. So Python 3 -n PENV is the command I'll type because I'm using Linux. Okay, we're just going to hit on enter and wait. So shortly, you're going to see this folder created down here with the name ENV. That's why I said you can name this anything straight away. But here, this will be the name of the environment variable. So ENV stands for environment variables. The idea is we're going to install all the packages for this particular project in this ENV environment, right? If you open it, you're going to see that it has bin, and inside the bin it has many other files, and you can see pip and Python right inside there. We have Python and Python 3 as well. Then you can also see the include and the library folder, which will all the packages will go inside, and the lib64. So once you have this ready like this, you are good to go. So we have just created virtual environment for this project. Okay, next thing we're going to work on is to create a file. We're going to use Jupyter Notebook for this analysis because I like working with Jupyter Notebook once it comes to analysis. So we're going to create the file. So I'll just call it analysis1 dot IPYNB. Note that what makes this a Jupyter Notebook project is this extension. This extension is IPYNB, is the extension. So let me just zoom in so you're going to have a look at it. That's it, IPYNB. All right. So this is what makes it the extension. All right. So once this is done, you're going to see this environment. I'll just quickly close the terminal. You're going to see this environment this way. So the Jupyter Notebook allows you to run your codes in cells, such that you can write one line of code, then you run only that one. It helps you to debug your code very fast, and it also allows for dynamic visualization and plotting of graphs right inside there. So that is why I like using it. So the first thing we need to do to work on this project, we're going to import some libraries that we need to work along with this project, right? Remember that the aim is to analyze this data, this particular data right here, then visualize it, clean it, carry out data pre-processing on them, then train the model as well, save the model and evaluate the model. That's what we're going to achieve today. So we're going to do a lot of plottings, and also I'm going to explain them so you're going to understand. So first off, if you are new to Jupyter Notebook, if you look up here, you're going to see code, markdown, run all, clear all cells, and many other options down here. And you're going to see kernel at the left hand side, right hand side rather, of these windows. So cell code is being used to insert a code cell where you can write a Python code, right? So all the rules of Python programming is applicable here. The indentations, functions, classes, you can write all of them right inside this cell and run them pieces by pieces. I can add multiple cells, like I can add anyone again. Then markdowns are for like comments. For example, this is a cell. So let me just say, if I say 3 plus 4 right away and execute this code. First off, Jupyter Notebook, since we are running it for the first time in a new environment, is going to ask you to select the Python environment you want this code to run on, right? Remember that we have virtual environment down here. So I'll just click new. You're going to see some environment. So you're seeing this env, which is this environment we just created at the beginning. Okay, so we're going to select this. These other ones are your global environment from your system. So why I like using virtual environment is because all the packages we're going to install will not go directly into our global system environment. Rather, it's going to be on this virtual environment, and it allows you to transfer your code or install it on other systems only based on the libraries that this particular project needs. All right. So now that we have activated the kernel, which is the environment variable down here, now our code can run. So if it's the first time, you might be asked to install the Jupyter Notebook extension. Let's just run it and see, right? Exactly what I said. So before you can run this virtual environment, you need to install IPY kernel package. So this IPY kernel package need to be installed. Likely every time you create new environment, this will come pops up for you to install. So what we just need to do is to hit the install button straight away and wait for it to install while it's installing. Let's just give it a few time for it to install. So many other packages will be installed down here. Remember, you need internet connection to get this done. All right. Once this installations is done, then your code will run and execute. All right. Okay, successfully installed. So now you can see that this code cell have now run, and we have 7, 3 plus 4, 7 right away. So what it means that I can just write this. I can say print hello, print hello, hello, just that way. So I can still run this one only, right? So this is the way Jupyter Notebook works. It allows you to run your code cells, right? Line by line, as in pieces in pieces. All right. So coming to Markdown, Markdown are used like comments. It allows you to write comments down. So code cannot run inside Markdown. Like I can say print statement down to print statement. All right, so this is just Markdown. I can click it, so it will be like a text comment. You can edit it and you can do many other things to it. You can also copy it and do every other thing to it. So it helps you to bring out an heading. So you can also do like add like hash to form a very big one, like so. Okay, so this is all what you need to do about this for now. As we continue to know much more as we proceed. Okay, so let's dive in straight to what we have today. We're going to analyze this particular data right here. So, and many concepts will be reviewed. So for us to do that, we need to work with some libraries called Pandas. So first off, we need to import libraries. So we're going to work with Pandas and NumPy, then Seaborn, Matplotlib, and Scikit-Learn. If you are new to this, Pandas is used to read data sets, right? Mostly used to work with data set, a huge number of data sets. And a data set is data like this, huge in number, as in like too much in number, right? So we use Pandas to work with it. While NumPy stand for numerical Python, it's being used to work with arrays, right? Anything list is what NumPy is being used for, like matrices, matrix manipulations, and every other thing. That is what NumPy is being used for. While Matplotlib is used for visualization of plots and many other things. So before you use any of these libraries, right, we're just going to install them, right? Okay, so for us to do that, we need to head down to our terminal straight away, print out the terminal. Remember, you need to activate the virtual environment before you install any package. So once the virtual environment is activated, you're going to see it at the right side this way. But if it is not deactivated, let me deactivate it. So you see how it will be. Deactivate, good. It's now deactivated. So you will not see it at the site here, right? But if it is deactivated, it's going to show this way down here. So just check it out if your own is activated or not. So if it is not activated, we're just going to activate it before we start installing the packages that we need to work with. All right. So to activate, if you are using Windows, you're going to type this command calling the folder name, which is the env. So you're going to start with env /script. You can also use / and / activate. This way is going to activate for you. Then you hit on enter. That's if your operating system is Windows, Windows 10, Windows 8, and so on, right? This is the command you need to type. This command down here, env /script /activate. So this will activate the virtual environment. But if you are using Linux, like I'm using Linux, we're going to type source, then env, which is the name of this folder, /bin, then /activate. All right. So before I hit on enter, let me show you where the command is coming from. Env is this folder name, right? Then the bin is this particular folder down here. If you expand the bin, you're going to see activate. This activate, then you call the activate, then that is what activates the virtual environment. So let me just hit on enter. So once activated successfully, you're going to see here the name of the environment variable down here. So you know that your virtual environment is well activated. So now we are good. We can go forward to install some packages, then we continue. So first off, I'm going to show you the packages we're going to use. We're going to use Pandas. So I'm taking you to the official site. I'm opening the Pandas now. Then NumPy straight away. All right. For Pandas, you can see this is Pandas documentation. You can come here and read more about Pandas and know what it's used for, right? Okay, so you can we will see the installation right from here. If you see install Pandas now, you're going to see the installation guide. Let me look out there. Oh, documentation. Let me go to documentation straight away, straight off. All right. Okay, then NumPy, I'll still open the NumPy down here, straight to documentation, where we're going to use it. All right, so we are here in Pandas again. We are here in Pandas, so we can now go to getting started, guide to Pandas. Right here, you're going to see that Pandas, these are ways you can install Pandas. If you are using an Conda, you can use Conda to install Pandas, but we are using pip right away. So this is the command you're going to copy and go and paste to install Pandas. If you are using Windows, copy this command, pip install Pandas. But I'm still going to head straight. Let me just copy this, then head over to my code straight away. Then I can paste it straight away. All right. If you are using Windows, you just hit on enter, but I'm using Linux. I'm going to copy 3 for it to install for me. So I'll just add 3 to it because I'm using Linux. It's just the package names that are different. So I'll just hit on enter, right? Okay. Remember, when you are doing this, you must have a steady internet connection for it to install successfully. So the same way, while this is installing, we're still going to go straight away to back to go and look for NumPy straight away. In NumPy, you can come to this documentation and read more about NumPy. You're going to understand what NumPy is for, what you can use it. You can use it to manipulate arrays of different dimensions, work with arrays, matrix manipulations, and so on. So you'll do well to come here to read more about this. The link will be on the description box below in this video. All right, so we can now go to get started and we'll grab the command to install the NumPy. All right, so the name of this package is NumPy. So you can also use pip install NumPy, right? So we can still go back while this is still going on. At the end of the day, we'll still install the NumPy as well. All right, let's just wait for it to load to finish. while we are still waiting, I'll still open Scikit-Learn, which is one of the package we're going to use. Scikit-Learn. All right, then Matplotlib as well. These are the libraries we need to get this work done, and also Seaborn. I'll attach all the link on the description box below. You can come here and come and read more about all of them. All right, so you have a better understanding of what they do. All right. Okay, they're still loading down there, so I guess I'll go back and check if it's done. All right, so I'm having something went wrong, so let me try it again. All right. So we're just going to wait for it to finish the installation, then we'll proceed. So guys, the installation of Pandas is finally completed, and we can proceed. All right, so once it's completed, you're going to see successfully installed, and alongside NumPy is installed because Pandas is directly depending on its need NumPy to work with. All right, so now other libraries that we still have, which we have just opened Scikit-Learn, we're still going to install Scikit-Learn, Matplotlib, then we have Seaborn as well. Since we have many other libraries to install Scikit-Learn, you can just go to getting started. Here, you're going to say how to install, and you can read about what it's all about on the documentation section of this application. So let's just go straight and install the remaining dependencies down this application. So since we have many, we're just going to write the command once. Pip3 install. Remember, if you are using Windows operating system like Windows 10, 11, and so on, we're going to use only pip3 install. Then I said we're going to install NumPy, Scikit-Learn, Matplotlib, Seaborn. So we can just type all of them once. So this is going to be Scikit-Learn. Then you separate it with a space, a single space, then NumPy, single space, then we have Matplotlib, single space, and last but not the least, all right. All these are used for visualization. So when we hit on one, install is going to install all these packages. This is shortcut instead of installing the long one. All right. So let's just wait for it to install. Then we're going to proceed on the analysis and loading of this particular data down to this environment. Then we're just going to start analysis and implementations. Thanks. All right, the packages are successfully installed. So the next step here, since it's done, we can just I clear it and remove the terminal. I don't need this terminal again for now. Once we need it, we'll bring it up again. So we're just going to import them. So import pandas. If you did not install it, you will not be able to import it. It will throw error for you. So import Pandas as PD. We're just going to use that short so we can use it to call the functions that are available there. Then import NumPy as NP as well as NumPy as NP. Then then import Seaborn, SNS, then NumPy. So we're just going to import matplotlib, matplotlib.pyplot. Let me execute this first, so we'll not have some issues again. Let's try importing it. All right, okay, it has been imported. So let's bring the last one. Import matplotlib.pyplot. Okay, as PLT. Then last but not least, for now, okay, we can just leave this for now. Then we want to train the model. We're going to import the. Let's just import it straight away. Then as we go, I'll explain it. Then from Scikit-Learn, this Scikit-Learn is the Scikit-Learn that we installed. The model selection. We want to import train test splits. This will be used to split the data set into training and testing. Then also from Scikit-Learn, dot preprocessing, we want to import standard scalar, then import standard scalar. All right, I will use it to scale the data sets, so we'll have everything. So the algorithm I'm going to use in this video is support vector machine, the supervised learning algorithm. So I'm going to talk about it expressly once we want to use it. So let me just import it. So you can access all the some of the models in Scikit-Learn. Some of the models are in Scikit-Learn straight away. I've already dropped the link of Scikit-Learn down there in the description box, so you can read more about it. Then from Scikit-Learn, Scikit-Learn.svm, SVM is support vector machine. We're going to import support vector machine classifier. SVC, support vector machine classifier. So this is okay. This is what we need for now. Any other thing we need, we'll import it as we continue. So guys, let's load the data set. So I'll declare a variable df. The df for meta stands for data frame. We want to read in this data set from here. This data set we want to read it to this environment for analysis. So I'll first of all declare a variable df standing for data frame. We're going to use Pandas pd.read because read CSV, because these are data set has extension .csv, right? We're going to read it as CSV, right? So this method will take the path of the data set, then and some other parameters it will pass inside there. So you could see a lot of things inside here. But for now, we just want to read the data set. Continue. So the path of the data set can be taken as 7. So ./ to get the folder data right away. You can see all the data straight away. Then / to get this the data set gestational diabetes data set. So now that we have this, we can now run the code. Down here, we can now check the structure of the data set by using df.head straight here. So the head function will display the first 5 rows of the data set, so you can see, but you can as well put specify how many rows you want inside here. In case I want like 15 inside here, I can just enter df.head 15 in it. So it's going to display 15 of the 15 rows of the data set. So in this data set, you can see that we have age, we have pregnancy number, we have weight, we have height, and we have BMI, heredity, and the prediction, which is the package variable. All these other variables, these particular ones, are being at a predictor variable, which is now considered to predict whether a pregnant woman is suffering from or is potentially having diabetes, right? Okay, so and that is what this means. So because this has a target um, outcome or a target label, we will definitely going to use a supervised learning machine algorithm to train this. We're going to train the supervised machine learning algorithm with this data set because it has a target output or a target label. All right, so that is it. Apart from the head, you can also want to see the tail. df.tail will give you the last end. df.tail. The tail works like the head. So it will display the last 5 rows of the data set for you to see. You can as well specify the rows you need in teaching, so to also display it for you. All right, so we can do many other stuff like df.shape to check the shape of the data set. df.shape straight away. I will give you shape of the data set. Sorry. Okay, df.shape. So I'll just run this. You see that we are having 1012 instances of the data set with 7 columns. This is the shape of the data set. You can do more to check by doing df.describe to see more about the data set, what the data set is about. The describe will bring out a descriptive statistics, including those that summarizes the central tendency, dispersion shape, and so on and so forth from the data set. So we can just run it. So we're going to see all these. We're going to see the count, total count of each of the variables, that's columns of the data set, and as well we're going to see the mean, standard deviations, and the minimum value in each of the columns, and 25% in each of the columns, as well as 15 and 75%. And you're also going to see the max values in each of the columns. This is what describe was. We can go further to check df.info. df.info will return the column information of the data set. We have the age, pregnancy test, weight, height, pregnancy number, weight, height, BMI, hereditary, and the prediction. And these are their respective data types. Okay, so that is what df.info will do, and it will show you more information about each of the columns now in the data set. All right, so we can as well check for null values. If there's any missing data in the data set, missing values in the data set, by using df.isNull, isNull.sum. So this will sum all the data sets, all the data that have a missing value. Sorry, it's going to be df.isNull.sum. isNull is a function. So that's what it's supposed to be. So from here you see that in each of the value age, it doesn't miss There's no any missing value in the age column, no missing value in the pregnancy number, and as well as weight. No, we don't have any missing value in the data set. That means the data set is complete with no missing values. All right, so guys, now we're going to go straight into visualization of this data. Okay, we're just going to visualize the data. All right, we'll visualize the distribution of all continuous features. I'm just going to bring a mark down here so I can write it down. Visualization of the we want to visualize the distribution of continuous all the continuous features in the data set, continuous features in the data set. So the markdown, this is what we want to do next, right? Remember, if you write code in the markdown cell, it will not execute. It's going to save as a text. All right, so let's just do that sharply. Remember that our data set is in a variable called df. All right, so we're just going to call the df. So df, then in the df, we're going to specify the columns that we're going to, columns or attribute that we want to visualize. In this case, we have age, pregnancy, number, weight, height, BMI, hereditary, and the prediction. So we will want to see the distributions of height, weight, height, BMI, and age, so far. So that's just what we want to look at. So we're just going to call them as an array the way they are spelled here. So you can easily copy from here, like so. Just copy this, you can highlight and copy, or you make sure you spell the same way it is, right? If it's not the same way, you're going to have some errors. So we can do weight down there, okay? Then we can do height, right? Right, height. Then you can have BMI. All right, so those are the columns we want to view the distributions, right? So we can now call on this histogram. We want to view it in histogram way. I want to visualize it using histogram. Then we want to specify the figure size for each of the histogram and give it a size. So figure size, let's give it 10 by 8. Okay, this is width, 10 width, and height of 8. All right. Okay, so I don't even know whether it's the same or what. I'll check it out. So you can check it out. Then we'll specify the size of each beam to be equal to 20. All right. So I think this should be beams. All right. So with this, we can now call the Matplotlib to visualize this for us by calling PLT. Remember that up here that we imported the Matplotlib, this Matplotlib as PLT and all those, right? So we're just going to call the PLT instead of spelling the Matplotlib, or PLT.type. We're going to plot the type layout, this type layout, so that we're going to have all of them visualized in one layout. Then we'll now call plt.show. The plt.show is a method that displays the charts, right? The chart. All right, guys. So let's just recap on what we just did. Okay, so first of all, we'll load in the data set. Or first of all, we import all the variables, and remember the data set is in our working environment folder called data. So we import pandas and all the libraries we need for now. We read in the data set. into the memory for you. Then we now store it in a variable called df. Then the df.help will give us the overview of the data, display the first 5 rows of the data sets, and df.tell will display the last 5 rows of the data set. df.shape is going to give us the size of the data set, right? Okay, and describe will give us the statistical analysis of the data sets. Then df.info will give us the column statistics of the data set and the check for null value. And now we want to do visualization of the distributions of continuous features, which are the age, weight, height, and BMI. So we just specify the columns you want to visualize. Then we call the histogram on it, specifying the size of the histogram, and we plot it using Matplotlib. Then we show it by doing Matplotlib, that's PLT, which we have imported up here as PLT, right? Then PLT.show to display the charts. So let's run it and cross our fingers while we see it run. Whoa, this is wonderful. So we can all see that we have age with the distributions of each of these variable height and BMI. These are their distributions. So from the chart, you can see distributions of each. Then we have data and how it goes. All right. So this is the first chart we have plotted so far. So let's just go up to C and just look at whether we can see some outliers. You know, it's a very good practice that when you want to train a model, you're going to look at the data set if there are some outliers. So we're just going to look if there's some outliers in the data set. So this is what we want to check now, outliers, right? We want to detect outliers and compare the distributions of each features of the age, weight, BMI. So let's just go straight and insert a new cell while we now all right. So we're still going to call plt.figure. First of all, we'll set the figure size of the plt that will display the figure. Then fixed size. Fixed size here is used to set the size of the figure, how you want the figure to be big, like this diagram here, how you want it to be big. If I increase this to maybe 10 again, it's going to be bigger in height. So that's just what fixed size does. All right. So I want to specify 10 by 6, that's 10 width and 6 height. Of the figure size I need. Then this time around we're going to use Seaborn to plot it. Remember, we imported Seaborn as NSS, SNS, SNS. All right, guys, that's it. All right, so this year we imported, so we'll be calling this anytime we want to use it. So we're just going to say SNS dot we want to plot box plots. Box plot will have to show the outliers. Then we're going to look at it. You know what to do with it. So box plot will take the data in question. So this data we are looking at the following columns, which is the age. Let me just grab it from the previous one. These are the columns we are looking at. All these columns, right? So let me just grab it from here instead of typing from my name. Somehow looking like a messy programmer. All right, that's right here. So I'll just paste it. Oh, whoa, I've copied another thing. So let me just try it. Yeah, that's okay. Just copy it. So let me paste it. Yeah. All right. So that's just what I want. So I've just copied this. So those are the columns in question. Then we're going to set some title. Plt.title will allow you to set the title of the system. So we'll just call it box plot of each weight and height. then behavior, right? All of them need to be in quotes, either single or double. All right, so that's what we need to do. So by now we can now go plt.show to show the plot. So let's give it a try. That's awesome. Okay. So now this is what we have, height, weight, and behavior. So we now have the plot. We can now see how this is, right? So this is the age, weight, height, and the behavior, right? So we can go further to do more analysis of here. So the next analysis we want to look at is the correlations of variables correlation. Sorry, I'm going to add back down. Variables correlation for relation between variables, between all numerical variables, features of variables. All right, so this is what we want to look at, guys. So we can also use PLT and set the picker size, PLT.picker, then the picker size, pick size is now, I'm going to set the picker size to be 8 by 6, 8 by 6, so it will not be too small because it's 8. Then we're going to use Seaborn heat map to plot the correlations of the data set. So remember the data set is df.core. .core is going to give us the correlation, and we're going to set annotation to true so that it will show those annotations, and we're going to set the color palette we want, and call it CM map. CM map will bring out the CMap, color map. That's the color palette that we need. Let's just use old one color. Okay, and what again do we need to consider? We need to consider the mini. Okay, this is going to be equal to -1. Okay, so okay, that's for the color palette, and we're going to do the maximum limits. Then this is just the if you check this, it's just the way the color will work. So we can use PLT dot title, setting of the title. We'll call it correlation features correlation with that. Features correlation. All these will be in the quotes, either single double quotes. So you just going to have that. Then you can now have PLT dot show. So let's just skip it. So now we have the correlations and features and switching correlation. The table can now show us how each variables correlate with each other. So the age correlate positively with the pregnancy number. The age correlate positively with the weight. So this direct positive relationship will be between age and the weight. The same thing with the height, right? The same thing with BMI, as well as hereditary condition. Okay, guys. So the next thing we're going to look at with this data set is to visualize the relationship between features. Okay, how each of the features relate to each one. So I'm just going to add up a markdown here that would show us a markdown. So we're going to visualize the pairwise relationship between features and how they relate to target value. So in this case, we are saying how each features relate to target value. So we're going to make use of Seaborn to plot pay plot. The type, what you need to plot is dependent on the type of chart we're looking for, right? So if you go through what I sent to each of the documentations, you will likely know different types of charts or plots that each of the library can give you. Then we now know how to go about it. So we are looking at the prediction here, the relationship between the prediction, all the features and the targeted value. Then we can have PLT.show to show the pay. So let's wait for it and see how it will be. So guys, while we are still waiting for it, remember to subscribe to the channel to get more premium videos on machine learning, like the even image recognition, even more. Remember, once subscribe, remember to on the bell icon so you're going to get notifications when I make more videos on this channel. Alright guys, so the plot is here, the pairwise plot. We can now see that the relationship between age and age, you can see now that it's just something similar to correlation table. It will always be okay. And so then the relationship between age and pregnancy number, you can see prediction 0 is the blue and the purple or orange is the 1. All right, so that's the prediction. No diabetes 0, there's diabetes 1. So if you check out here, you see that no diabetes here is somehow small. No diabetes is more than there's diabetes, and also something like that here. So you can now have a look at it, know how it goes. Alright guys. So the next chart we're going to look at up here, we're going to visualize the distributions of the multiple variables right here. That is, let's say, okay, the visualizations of the hereditary and the pregnancy, that's what we're going to look at. How they look, and this is all about the data analysis. We're just going to bring out the chart matters to understand the data which we're going to look. So first of all, I'm going to bring a map now. So we're going to visualize the distributions of categorical visualization of hereditary and pregnancy. Permit me to remove this visualization of hereditary and pregnancy of pregnancy number. So guys, let's just go straight away there. Then PLT.figure size. Remember, we're always going to set the figure size, so it will not be too small and it will not be too big. So this will be fixed size equals to, I'm going to make it 10 by 6. 10 by 6. Okay. Then we're going to use Seaborn to bring up the count plot. Then we're going to count the x and the count plot is going to count the hereditary. Hereditary, while the hue now is going to look at the prediction. Based on the prediction, like what this is showing is the number of hereditary that is classified to prediction. That is, you have, there is a diabetes or there is no gestational abilities. So the data in question we are looking at set data is the data set, the complete data set. Then let's give it the title EOT and all right. The title will just check the count of pregnancy percentage. Pregnancy number. Pregnancy number percent. Hereditary. All right. So we can now show it now. Here, all right. That is one. We can still drink up another one. That is hereditary percentage. Then I'm going to do the same for pregnancy number. So let me just copy this and paste, change the pregnancy. Remember, this column we are calling now, this must align with the columns we are having here, right? Like this is the pregnancy number, how it is spelled. You need to spell it that way, or you can change the column name to what you want. You're going to get it. So pregnancy space number straight to it. This is a ready. Oh, well, the title is not correct. This is supposed to be prediction physics. The pregnancy number physics. Hereditary physics. Pregnancy prediction, sorry. Versus prediction. Alright, this is what it supposed to be. Prediction. Alright, while this is supposed to be pregnancy number versus prediction. Alright, that is what it's supposed to be. That is the prediction with the bracket value. Alright, so we can now see. Alright, so we have the prediction 0 to the no diabetes to the blue, while the orange is the diabetes. So you can see that hereditary, in the data of hereditary, we only have yes or no, that's 0 and 1. So that is why hereditary 0, no, there's diabetes is small. This is the portion of it around getting to 100. There is hereditary history of diabetes in the family is more than that of no history of diabetes in the family. All right, so we can also have the chart for the pregnancy. Depending on the pregnancy, we have how many numbers of pregnancy it is. 1, 2, 3, 4, 5, 6, 7, 8. See that the highest of it is 3, right? Let's compare this. Okay, guys. So these are the analysis here. Then okay, let's just look at what we call Pauline plots. Pauline, right? So we're going to visualize the weight with respect to the target variable. And we have already done that, but unless I'll just show you how to plot Pauline plots instead. Let me just show you because we have already done distributions of weight, BMI. So let me just put in Pauline plot distributions of distribution of weight, BMI, etc. weight, BMI, etc. with respect to the target value. Respect to the target. So that should be the target variable is prediction, right? Using file this. All right, so let's just do it using things. Whoa, announcements. So, all right. So let's just plot it for link plot. I'll just plot one. Then PLT dot figure size. I'm going to do it 10 by 6. Figure size. Yeah, fig size, which is going to be 10 by 6. 10 by 6. Then I'm going to use SNS, that's Seaborn, the following plot. Then I'm going to pass in X to be the prediction, that is the packet prediction, while Y is the BMI, right? Then I'm going to pass it to be equal to the different itself. Then the next thing, the title, I want to say PLT, the title. I'm going to call it distribution issue. Distribution prediction. Distribution prediction. All right. Listen. Right. Let's show it and say PLT show. Right. First, I will think that's why we run the video. Okay, so this is a following plot. So you can have a good look at it now. All right. All right, guys. So that is what we have for now. The next thing is we have done several analysis here. These are some good analysis you do depending on what you want to achieve. Analysis is always strictly depending on what you need to see. So the next thing we're going to do here is to split the data set into training and testing. Train what the support factor. So first of all, I'm going to split the data set into training and testing. That's dependent variable and independent variable. If you remember, we have some variables that will determine the dependent variable, which is the X. All right. Okay. Assuming you have this formula y equals to mx plus c or minus c, whatever the case may be, plus c, then this is the dependent variable and this is the independent variables. Why this is the slope? In this case, we are talking about a multi independent variable. So we're just going to split the data set with df.drop. df.drop will drop the column we specify inside here. So we want to drop the prediction because the target variable is now the dependent variable, right? The target variable is the dependent variable. We're going to drop it there so that we'll have we're going to have only the dependent variable on X, right? Only the independent variable on X, sorry for me. While we will have the dependent variable Y, right? On here. Let me just bring out this. Say you have Y equals to mx plus c plus c. So you know this is the dependent variable. This dependent variable, this is the independent variable slope and the error, right? Slope and error. This is plus c. All right. So we are doing something similar to this, make something closely similar. So now I will now put the dependent variable, which is the prediction in the y, this y. Remember, in supervised machine learning algorithm, there's always a targeted label, right, that will be exposed to the model so that the model can map the independent variable to the output, which is the dependent variable. And the algorithm will learn with it, which later more other data can be given to the algorithm, then to the model, then we'll be able to predict it. All right, so that's just the idea behind all this. So here, then we're going to bring in the prediction straight away. Now the prediction is in this dependent variable. So let's split the data set now into training and testing after we have split it to something like this formula, like so. So we're going to use xtrain. We're going to have variable xtrain, and we're going to have variable xtest, and we're going to have y-train, and also y-test, test, right? So we're going to go on the train test split to split the data. If you remember that we imported it up here, this train test split is what we're going to call down here and pass in the data and set the proportion how we want to split the data. Then the data will be split. So let's just call it train test split straight away. Then we're going to pass in the x, which is this we are preparing. Then we pass in the y as well. Then how do we want the proportion of the splitting to be? We want to use 80% for training, while we want to use 20% for testing, because the training data need to be more than the testing data. So we can pass in 0.2 representing 20%. You understand? 20% of the entire data for testing, then the remaining will be used for the training method. Then random stake, we're going to leave it at 42. The random stake will control the shuffling, how the data set is being shuffled. That's what the random stake does. All right. So I'm just going to leave it at that. Then the next thing we're going to do is the standard scaling. We're going to scale the data sets, right? So, and if you remember, we have already imported the standard scaler up here. This is the standard scaler from Scikit-Learn. Okay, so we're going to scale the data so that there will be no overfitting. So I'll just call this scaler equal to standard scaler. Standard scaler, then we're going to this is the instance of the standard scaler. We standardize the features by removing the mean and the scaling to the unit variance. So this is the formula down here, the standard scaler, where U is the mean of the training sample, or 0. So that's just what it does. So we're going to scale it straight away. So let's create another variable, xtrain. We're going to override the xtrain will be equal to, then scalar. We just created the instance of the standard scalars for us. Then we're going to use it to scale our data. All right. Then scalar dot fit transform. So we're going to pass in the xtrain. All right. Then the same thing we're going to do for xtest. This is supposed to be x test. All right. So x test equal to scalar dot transform. So X test. So the standard scalar is done. We can now run this. Right, everywhere is good. So now we're just going to create the instance of the model, support vector model. So I'm going to call it SVM model. Model is equals to SVM model equals to. Remember, we have SVC. We have already imported the SVC up here from Scikit-Learn SVM. Down here, we have XVC, that is support vector classifier, which we're going to use is a classification algorithm we're going to use to classify these tags. So we're going to say the instance of SVM, then I'm just going to say probability equals to true, so that we can compute some. This in then random state as the shopping state again is going to be 43, right? Random state 42. All right. So this is the instance of this support vector machine. So we can now move straight to training the model. To train the model. The model with the data that we have scaled, we use it to train the model. So we can say SVM model dot fit. The fit method is used to train the model. So we pass in xtrain and ytrain. Xtrain and ytrain. Remember, they are the data that we scale up with. All right, so that's what we have. We can now run it, wait for it to train. So this is trained. The next thing that the model has been trained, we can evaluate the model now to say the model is performing. So the model evaluation is what we are going to do now. We're just going to pass in, I can just bring out a function that will bring all the evaluation metrics for the model, right? So let me just bring out this function here that will evaluate the model. So I just created a function down here that will evaluate this model. So to evaluate the model, now we need confusion metrics because we're going to compute the confusion metrics of this model. After the confusion matrix is being computed, we're just going to print it and check out everything about the confusion matrix. I will know what to do. Or you can do it one-one. Let's do it one-one so you will really understand. All right, guys, let's compute the conversion matrix and evaluation matrix. Let's evaluate the model. So we can say model evaluation. Evaluation. That's what we want to do next. All right, to evaluate the model, how well the model performs, first of all, we need to test the model with our testing data. That's do prediction with the testing data of our model. All right, okay. So we can just pass in y grade, or let's say grade is equals to model SVM model SVM model dot predict. We call on the predict function to predict the data. So we'll pass in the test data we created down here. Okay, so we can just run it, then you can check the results now. Right, like so. Check, you're going to see all of the prediction from data that we have split. So this is the possible predictions for all. Okay, so let's evaluate the model and see how the model is performing. First of all, we compute confusion matrix.
So the confusion matrix is used to see the real performance of the model. I'm going to say CM equals to confusion matrix. So we're going to import the confusion matrix from model.matrix. So we're going to say from Scikit-Learn.matrices, from Scikit-Learn.matrices import. We're going to import confusion matrix. Confusion matrix. We're going to import precision score down here. We're going to import recall score. We're going to import F1 score. Then we're going to import again ROC down there. All right, and then that's what we need for now. Okay, confusion matrix ROC, and then we're also going to plot it. We're going to plot them. So we're going to import confusion matrix display. Then we're going to import confusion matrix display. Yeah. Then we're also going to import ROC form display. I think let's just stop the for now while we do this. All right. So now that we have this, we're going to clear this. All right. So let's go down here and go and display everything. So we're going to complete confusion matrix first. Confusion matrix, then we're going to pass in the y test, and the y prediction. So I'll call it predict. Look at the prediction we did. All right. So that's what I'm calling. So down here, you could see the confusion matrix down here. So if I plot it, these are the confusion matrix. Confusion matrix is used to measure how good the model performs, and that is it. Then apart from that, you can just also get the report of the model. You could get the report of the model to just log in models from maybe down here after training this model SVM score. You could get it. And let me just come here and show you the SVM model score. So these we run. Oh, we got some errors. Okay. The score states the x and the y this thing. So that's y, the x trend, and the y. I guess all right. So this will give you the score, the training score of the model, right? 0.89% accuracy. So that's what is going to give you for them. So let's continue, guys, and visualize this. And we could visualize this confusion matrix by using the confusion matrix display down. So let's just visualize it. And we're just going to stop it here for now. Then confusion matrix display. Then it's going to take the confusion matrix. Confusion matrix, that's the CM that we created down here. The confusion matrix itself. Then we're going to plot it. Plot the confusion matrix. We map the color map to the green. All right. Right. Then we can set title plt.title. Then you can set the pushing metric. Right. Then we can show the period of sheet. So let's just show it. See, this is the confusion matrix of the model. This is a sad thing you love where you can now visualize it in this way. So guys, this is how to train the model. We have trained the model successfully. If you want to save the model for future use or to deploy somewhere, we create a folder and call it models down here, like doing it this way. Then we're going to import job up here. Let's just add one more dependency. I'm going to call it import job lib, all right? Job lib down here, this job lib. So I'll run the cell. Let's go and save the model with just string down here. So I can now call job lib dot dom. You call on the dom function, then you pass in the path, the file path where you want to talk with. So dot forward slash, you want to put it on models, then you want to give it a name. I want to give it a name. The name is going to be SPM underscore model underscore name. That's version 1. All right. But the model itself, you're going to pass it in the value of the model. Then the model value is the SVM model. Then this is the path we're setting it to. So we can just hit down here in the model itself. Then we can verify it. This is the name. So guys, this is the end of this video. In the upcoming video, we'll be talking about another analysis and how to do more complex things and even natural language processing. If you like the video, do well to subscribe to my channel, on the bell icon, and share it with your friends. Give me a thumbs up on my video and support me by following me on the channel so I'll record more videos like this. See you guys in the next video.